Hello everyone! This is a new video in my basic electronic component series. Today I'm going to take a closer look at one of the most exciting building blocks in electronics. Op-amps, or operational amplifiers. Op-amps have a lot of applications in analog electronics and of course in DIY synthesizers. Op-amps are around since the 70s, and today I'm going to take a closer look at this versatile building block and of course in their application in analog DIY synthesizers. If you like this video series, you can support me on Patreon. You get early access and discount in my online store. Alright, let's get started. Alright, let's take a look at op-amps today. So they come in different packages. So those are through-hole dip packages. So this is a quad op-amp, for example. This is a TL074. This is something I use a lot for my DIY builds. This is basically the same, but there are only two op-amps in this package, and we have the same for SMD packages. So those are a bit bigger packages here. So this is also the 72 two op-amps, and this is a quad op-amp here. This looks the same. Also from the pin out, this is the same. So it looks like this. Yeah, this are also the 74s here. I use them a lot. They are not very expensive, and I think they have a great value. They're around for a long time, so I think they're around since the 70s. But they're still in the making everywhere, and you can get them everywhere. So what we can use op-amps for? There are different applications. I'm going to start with the most simple one. So the symbol is like this. You have an inverting and a non-inverting input and an output. The most simple configuration is this one here. So this would be just a buffer. So basically, if you have some voltage here, it will be copied and will be the same here. So this is something we like to use, for example, if we don't want to interfere with the schematic that is happening here, and if we, for example, need to get some current out of here. So, and in this way we can copy the voltage, and this will not interfere with everything that is happening here. So usually if you build a synthesizer module, you will usually have something like this at the input and the output, because that would make sure that none of your other modules will be affected by drawing too much current by your module. So this is, I think, good behavior to do this. The next configuration is a form of this one here. This is basically when we add a voltage divider down here. It will look something like this. So we have a voltage divider down here. For example, here's two different resistors. Then for example, if the resistors are the same value, then half of the voltage will disappear to ground here, and that would mean that the op-amp needs to push double the heart to reach the same state as we have in the simple dual output, and this would mean we have amplification by 2 in this setup here. So there's an easy formula. So the amplification or the gain for this configuration would be 1 plus R2 divided by R1. So in this case, if those resistors have the same value, then the application would be 2 in this case. Very easy, I would say. So this is very useful if we want to amplify some signal. As you can see here, we have this 1 plus and then the ratio of our resistors. So this means we can only have gain of at least 1 and more. So this brings us to the next configuration we have with op-amps. So this is an inverting configuration, and this looks like this. So we have the negative input here and some resistor in front, and then there's a feedback resistor. We have the same here, R2 and R1, and this is in this case, for example, going to ground. And this with this configuration we could also have a gain which is less than 1. So the formula for this one here would be just the ratio of those 2 resistors. This would be R2 divided by R1. So for example, if we have the same value for the resistors, then the gain for this configuration would be -1 because the whole thing is inverting. And you could also have, for example, half a gain of 0.5, for example, if you put something like 100 and okay, there's no 50, 74 ohm or something in here. So we would also have, you could also have a signal which goes in here, but it's negative, of course. So those are the basic configurations for op-amps, I would say. What I think maybe to add to the inverting one, what you see a lot is you can also mix multiple signals here. So you can add more resistors here and basically mix signals, and they also could be different resistors here. So the ratio would be different and the amplification. So you could mix different signals together in different proportionality. So I think this is a very nice application. It's also simple mixers basically work like this. What you usually do, then you have another op-amp here which then inverts the signal again, so that you have on the output, you have the original signal basically. So it inverts it again. So this would be an easy application in synthesizers, for example. So this would be an example here. On the input, you have this inverting configuration here, and there's no gain. So this is the gain is 1 here. But this buffers everything here, and for example this is DCO, and to not so everything here will collapse if you draw current here, so you also have a buffer on the output. So this is what you usually do. Here another example, this is my analog VCO design. That looks very similar here to the DCO, but also here is some buffering on the input and on the output. So and that the charge is not collapsing here of the oscillator. You buffer the outputs. So this is just a simple buffer, as you can see here. This buffers, but also is used as a comparator because you have a variable voltage which comes in here, basically. But the application is more or less the same. So I made this easy sheet here because I tend to forget, especially the pinouts of the different packages. So there's also a package with only one op-amp in, but I tend not to use those because from a cost perspective, I think they more or less cost the same. So the problem is not the op-amp itself, but the packaging and everything else. So yeah, usually also you try to, if you build some schematic, you try to like use one of those packages here and just have enough, so you adapt your schematics so that you can make use of all the op-amps you have usually. Yeah, so here are the basic configurations again, so you can find this also on my Patreon if you like. Alright, that's all for today. Make sure to check out my online store. I offer all sorts of UREC modules that are easy to build. Alright, thanks for watching. See you next time.